Hello, everybody. In this session, we will go over multiple choices and examples from questions that you might see in the exam. This is a file that includes many kind of questions. It's a good review for you to go over to prepare for the exam. Many of those questions will show in the exam, and of course with a little changes, but it's a good file ready to go over. I will start from the second part, which is the SQL questions. We didn't go over those in class. I did upload a file with SQL file with all the comments, but I think it would be good if you would go over those kind of questions. Will give you a good idea what you might see in the exam. So let's start. Question about the SQL. First question: which of the following statement is true? Okay, and the first one is really related to a concept called view. Okay, to remind you, we're writing a view in a very simple command. It will say create view, you give a name, as, and after the as, you simply write an SQL command of select. In another word, you create a select to pull data from several tables that already exist in the database. And that select, you want to give it a name. So a view, in another word, you can say it is giving a name to an SQL command. Or in another word, you can say that view is a virtual table in the sense that it's functioning like a table, but it's based on data from other tables, okay? All the rest really are nonsense, so I won't even go over them. Question number 2, when do we use a bridge table? And that should be familiar by now. We went over that several times. A bridge table you have to have in case you want to have a many-to-many relationship between two tables. For example, if I want to have a relationship between students and courses, I can't have a many-to-many relationship between those two tables unless I would put a table in the middle between those two. Why? Because every student can register to many courses. So it's already one too many from the students to the courses, it's one too many. But it's also true for the other way around. Every course, there are many students can be registered to. You cannot really have these relationships unless you put a bridge table, okay? Therefore, A is correct. To connect tables in many-to-many relationship, you have to have a bridge table. Pay attention that in a bridge table, you must have at least two columns, one connected to one table and the other one to the other table. What is a primary key? We went over that also several times, okay? We saw in the dimension tables, we add a column called primary key. Moreover, we make sure that that one will be a whole number because it's the least consuming from a memory point of view, and it makes it work very fast in a cube. So a primary key, it's a field that has different values for every record, and it comes to distinguish one row from another. Again, the rest is really nonsense, so I will even skip those ones too. What is an SQL? Now, SQL, we mentioned that in several occasions, mostly in selecting data, inserting data. In the video I made for introductions to SQL, I mentioned the update command. We saw the insert in when we inserting data into dimension tables, and there's also a delete command. So there are really four commands in SQL that are classics. And in fact, B, it's a language to create, retrieve, update, and extract. It's correct. And in fact, you can really remember them by CRUE, called the CRUD commands. So B is correct. You can do all of those ones to manipulate, pull data from tables. So that's regarding the data that contained in tables. C and D relate to creating objects in a database. So creating a database, it's also an SQL command, but it's creating the database itself. And in C, we're creating the table itself, although empty, but it's creating the tables on which we can apply all the four types of SQL that we have in B. Therefore, answer number A, it's really that all the other questions, all the other answers, I should say, really are correct. Let me fix that up here, and I will upload the correct one. Okay, let's move to number 5. Which of the following statement is true? In every table, we have records and fields. Yeah, record means a row, and a field means a column. Well, classic, very simple. All the rest is really nonsense, okay? Don't get confused. A C might seem right to you. Every record in a table represents an entity. Doesn't have to be correct. It's true for a table like customers. It's true for a table like items, for inventory. But sometimes you might have a table that represents transactions. And transaction is not exactly entity. Some might argue that even a transaction is an entity, but in the classical definition, it does not. So C is not the right answer. A, it's the most correct one that you can't really argue with, okay? Let's move to question number 6. What is a foreign key? And here we use that many times, okay? When we connect a dimension table to a fact table, in fact, in the fact table, it's automatically creating what is known as a foreign key, which is connected to the primary key in the dimension tables. Therefore, answer number A is correct. Used to connect one table to the primary key of another table. In the example I gave, we're connecting a column in the fact table to a column in the dimension table, which is the primary key of the dimension tables. Let's look at 7. We used ERD without even noticing when we created the links between dimensions and fact tables. We used the diagrams in the Microsoft SQL diagrams, and we connected the primary keys to the fact tables, okay? And that chart, it's known as ERD. And ERD stands for Entity Relationship Diagram, okay? So B showed the links between tables, that's correct. The diagram showing fields in each table. If you recall, in the diagram we saw that in every table we see all the columns that we have, and one of them is the primary key. If you recall, we have a little key next to the primary key to identify it as the primary key. I even mentioned many times, when you do the link, click on that key first and then drag it to the fact table to connect it to the fact table. Okay, question number 8. What is inner join? And many times you can really ignore the word inner, and it works as good as if you put the inner, you automatically assume, if you don't put anything before the word join, that it's an inner join, okay? In these connections, we get only records that have the same values in the columns used for the connections left and right. What do I mean by that answer? And if I give it a question like that, hopefully you won't get confused, because it seems like confusing. Let me explain that. When we connect two tables, let's call the first table table A on the left side and table B on the right side. What do I mean by left and right? We write a command, select star from, and then we write a name of a table. The first one I call the left table, okay? So we'll say from table A, join table B, on, and the on will show which columns in each table we're connecting to each other. So left and right means to the tables I'm writing to the left or the right of the word joined, okay? When we do a joint connections, it will join only rows from table A and table B that they share or that they have the same value in the columns we're connecting, okay? Therefore, if I have a table A with 100 rows and table B with, let's say, 150 rows, but only, let's say, 80 rows in table A and 80 rows in table B, in the column that we're joining them, they share the same, they have the same values, so only 80 rows will be shown in the results of the query, okay? Therefore, when we use joint, it will be only rows that in both tables have the same value in the columns we're joining those two tables together. Please see the video I made for Introduction to SQL. What is a left join? Left join is an extension of joint. The idea of left joint means that the table you're writing first, meaning in my example for question number 8, it's table A, okay? What it says is, if I use a command like select star from table A, left join table B, it will show me all the 100 rows of table A. It doesn't matter if the row in table A has a match in the column of connections with table B. On the other hand, from table B, it will show only the rows that have a matching. In other words, here I used left join to make sure that I will see all the columns, all the rows in table A. Okay, the rest are meaningless, so I will skip them. Question number 10, okay? What is a query? By the way, just before I continue, move on, there's also right join. Right join means show me all the rows in table B, regardless if I have a match in table A, okay? So, and there is also a command called outer join. In outer join, I will see all the rows in table A and all the rows in table B, okay? Regardless if there's a match or not. Please see the video that I talk about it more in the, about introduction to SQL commands. What is a query, okay? And here it's a little subtle because we use the word query in a general meaning every SQL command, but it's already true. A query, the word query usually refer to the retrieve command out of the form I mentioned above. The retrieve means select, okay? The command select is what we refer usually in query. In query, we're simply pulling data from tables, okay? So a query is a command to retrieve data from a database table. In fact, I should even say slash tables, okay? Or let's put in parentheses tables. It doesn't have to be one table. It could be several tables. What is integrity? We have used it without giving the name, and it's very important to know the word integrity. And integrity refers to the fact that if I have several tables presenting the same data, the data in those tables will not contradict. For example, if I have a customer name in two separate tables, it's better off that the spelling will be the same. Otherwise, I will think that we relate to totally different customers. That's why when we're doing BI, we use the dimensions and we make sure that we have a customer dimension. In this way, we have one table that includes all the data regarding the customers, and then we won't get confused, okay? That's really one of the reasons In addition, we use foreign keys. So when we connect the fact table to the customer tables, to the deemed customer tables, we use a foreign key to make sure that whatever will be in the fact table will be consistent with the dimension table. Or in another word, I will not put an index for customers in a fact table that doesn't exist already in the dimension tables. Okay, and finally, for every entity tables will have a primary key. I just gave example of customers. It's true for items or any other entities, institutions, course even could be an entity. All of those will be as a dimensions one. What is auto increment? Auto increment we also used, and if you remember, when we created a dimensions table, we used the word identity and parentheses 1, comma 1 in the primary key of the dimension table. What that one does, it automatically makes sure that the table in that column will be filled automatically with 1, 2, 3, 4, and will make sure that every row will get a separate number in that column. That's what means auto increment. It's implemented in Microsoft by the word identity. Other databases using a different syntax, okay? But the idea is the same. Or if I read the answer A that it's the correct answer, in a database, the primary key is a field automatically filled with unique whole number, okay? Let's move to question number 13. What is truncate? We use that along the course. We use truncate to empty the table. But truncate is different than delete. In delete, we're deleting row by row from a table. We can use a delete on every row and then we're emptying the table. But that will be very inefficient and time consuming. The best way to do it is to delete the whole table and recreate it automatically. And truncate does just that. It's delete and create the table again. And therefore it does it very fast and very efficient. We also saw over the course the command drop. Drop is, you can say half of truncate really, only the first stage. It's simply delete the table and doesn't create it again, of course, okay? So that's a good way to delete the whole table with the content inside it. Question number 15. Here, as you see, and that's the way I will do in the exam, I will give you SQL command and see if you can understand it. I call it a passive knowledge. It's not active like asking you, please write the command. Writing it's a little more advanced and I'm not ready, it's only introductory BI course. Therefore, I will provide you with a SQL and I will ask to see if you can really understand what that command does. For example, in this example, we're selecting everything. The star means all the columns. From where? From those two tables, customers and orders, okay? But in order to know, to get the data, I must link those two tables. I can just call the names and without saying how I'm connecting those two tables. And the connection is in the where command. I'm connecting the customers table with the customer number column with the order table with the customer number column. In other words, I have two tables. In both tables, in each one of them, I have a column called customer number, and I'm connecting those two tables by connecting those two columns. That's the first part of the where. You should really remind you that this is really similar to the inner join we saw above. But the where also function to filter records, and that's the second part. It's filtering all the rows, or in other words, it's going to show me only the rows in which the first name is Jean in the customer table. C for the customers and customer first name, it's the column in the customer's table, and only the rows in which it shows Jean. Okay, so therefore all the other answers are correct. Let's see what the other answers are. It shows all the records of customer with the name Jean. That's correct. It shows only customers that already purchased in the past, of course, because otherwise they won't show in the order table. Order table include only customers' orders from customers that are actually purchased. If they didn't purchase, they won't show in the orders. And since we have an inner connections here, okay, inner joint, it's similar to the inner joint, then if they didn't purchase before, they won't show in this query. Let's say D, shows the details of the orders without the product. Of course, because we don't have the tables of the product connected. We have only the customers with the orders. We don't really have the details of the orders in this SQL. Therefore, I won't see any information about the product. That's a little tricky questions, not really, but at least it's really expand. If you know really this SQL and you understand it, you're in a good shape. Question number 16. What does the following command result? Meaning, what is the outcome of running a query like that? This one. Okay, so let's take it step by step. The first one, we see the select, we see the from, we see the where, and we see the group. We use the group in order to carry out some aggregation functions. Aggregation functions include sum, count, average, etc., mean, max, and others. The most important things to notice that in this select, I must have the column in which I would like to aggregate the results. In this example, I want to aggregate by the order number, or in other words, I want to aggregate the sum of the prices for each order. Okay, that I must put in the select. In the select, I have the column in which I want to aggregate, and here I write the aggregation function and on which column I want to apply it to. The S total, of course, is just giving a name to that sum, okay? Secondly, and don't forget it, otherwise you will get an error, you must put the group by in the end of the command. So this one and this one must be the same, otherwise we will get an error, okay? So this select will give me the total amount of every order. I would like just to mention, a little tricky, this is a little might be confusing. I should really say the assumption here that I'm selling one item, okay, from each type of a product. Otherwise, this one will not be correct. If I sold 2 items, then I should multiply the quantity by the price in order to get the sum, okay? So, but the right answer in this case is that I'm getting the total amount for every order. Don't get confused if in the exam, I will add here times, okay, times quantity. Let's make a little more sense if I really want the total of every invoice. But if the quantity is 1, then I don't really need it to multiply by 1, won't change the result. Question 17, it's another select example. And when you see a select like that in the first site, it's getting, you're very confused. Don't get confused. Don't get scared. Just go by the rules. I see in the end the group by. So that means I'm going to aggregate by an aggregation function. And indeed, in the select, we see aggregation function. So that makes you feel good. Very similar to the previous example, okay? The second part, what am I aggregating by? And here I'm aggregating by the year. And how do I know that I'm not wrong? Very simple. The same as I have here year of the order date, I have the same things right in here. And I'm ordering by the year component of the date, okay? So this one and this one telling me that I'm integrating by the year, and this one telling me that I'm summing over all the quantity times the price and aggregating all of them for that specific year. Now, we have two more parts of this SQL. If I just look at that and ignore what's in the middle, I'll be in a bad shape. I mean, in a bad, I will get the wrong answer. And the key point is what the rule of the where. The where is acting before the aggregation function, meaning, first of all, what the select does is combining the order table with the order detail in an inner joint. Here is just a syntax that is using the same column in both tables called order number. Very important to notice that it's first sort out only the rows in which the status is shipped, meaning I'm getting, okay, total sales for every year for a record for orders that already shipped. So if I had an order and I didn't ship it, it will not be in this answer. Therefore, let me fix the answer number A. Is the total sales for every year of orders that were shipped. Okay? I probably forgot to add it when I translated it from Hebrew. In fact, I wrote that one in Hebrew first. So my apology. Okay, and this is the right answer. Okay, let's move on to the next question. What does the following command result? This one even simpler than the previous one, much simpler, in fact, I should say. We have a select, we have from and where, very classical questions. We selecting the data from the employees table. How many columns I have here? I have 3 columns, last name, first name, and the job title. It's coming from the one table employees. And the only thing is that I'm kind of filtering that I'm not getting all the employees, I'm getting all the employees that the job title is sales rep. And that's really what the A means. Information of employees from the sales rep. I could have added that I'm getting only 3 columns. All the others are not correct answer. Let's move to 19. Which of the following prevent duplicates of records? You already know that a primary key's role is to make sure that every record in the table is different than other row, okay? And that's why we have a different number. You could say, what about the table of inventory? I have a primary key for every item in the inventory table. But if I want also another column that will not be a primary key because it will not be efficient in connecting it to a fact table, but I still want to have the code for the item. Many items you will see a code that the supplier might use or whatever. And that's one, it's not a whole number. Can I still force that that column will be a unique in the sense that I will not give the same code to a different items. So every item will have its own code. The way to ensure that it's defining that column to be a unique index, okay? The purpose of that is to make sure that I won't duplicate the same code to different items. But I usually will not use that column to connect to a fact table just because of performance. We always use primary key as a whole number for performance purposes. Next question is just to make sure, in fact, the next 3 questions dealing with the same issue, knowing the data type that we might have in a table. So the first question is, what is a float number? Float number is really a decimal number just usually databases define float with 4 digits. Some databases, by the way, might define it with 6 digits after the decimal point. Okay, but most of them are 4. So float number, it includes a whole number and decimal numbers up to 4 digits after the point. Pay attention, I added the whole number because a whole number with 4 zeros after the decimal point, it's still a whole number, okay? It will write it as a decimal point number, but it is a whole number, so it's include the whole numbers as well. So don't get confused on that. And this was the purpose of this question, not to forget it. The next question, it's which data type should we have, which data type should have a field course number. So when I'm preparing a dimension table for courses, which kind of a data type I will use, you already know that I really should use an integer, which is a whole number, okay? Please, if I put, and I might, a big integer, will that answer the question? The answer is yes, definitely yes. When do I use a big integer? It's really just an integer, just allow me to use many more numbers. So if in an integer it's 7 millions, big integers can get to billions of integers, okay? So the difference is really up to which numbers I can use. So in huge tables, I might use even a big integer, okay? Varchar, it's of course for characters. Float, we mentioned before. And decimal, the difference between decimal and float really is how many digits I have after the decimal point. In decimal, I can control that. In float, it's already given to me by the system, by the database. Question number 22, just wanted to emphasize that varchar can allow me to define how many characters, the top numbers of characters that could be in that column. Varchar was designed that if I have a very big table and I want to save space on the hard disk, and I know that the sum of the record will have, let's say, 2 characters, some of them 10, and some of them 13, okay? To save space on the hard disk, when I use varchar, the computer or the database, I should say, will allocate memory on the hard disk according to the actual number of characters I am putting. But the maximum that it will allow me to put in that record is 13 characters. Therefore, answer number A is correct. Data of up to 13 digits and characters. It could be a number, it could be any other characters. The rest are incorrect answers. With which SQL command we can get the number of records in a table. I mentioned that, and it's also in the video that I gave you on Introduction to SQL. Very simple command, it's count. You simply write select, count, open parentheses, put a star inside, form the table name, and you'll get the number of records in that table. All the rest are just nonsense. Sum will sum whatever column you will give. So in fact, some will not take even a star because it will tell you an error. When I use a sum, I have to specify the name of a specific column. And if I specify prices or quantities, and quantities might have more than one in that row, then the sum will not give me the right answer. Okay, let's look at the next 3 questions. We have some information regarding those 3, so let's look at them. You were asked to build a database of an academic institution, and as we know, you need to have several tables, including one for students, courses, and lecturers. So how will you do the connections between those tables? So let's look at the question number 24. Which type of a link you should establish between the courses table and the students table? And the link is many to many. How should you approach a question like that? You should really ask yourself, okay, I have courses table, I have students table. And then you ask yourself, every student can register to several courses. So from students to courses, there should be a link of a type of one-to-many, because every student can register to many courses. Then you ask yourself, can many students register to the same course? Or in other words, is a row in a courses table that represents a specific course can be linked to several students? The answer is also yes. So I have one-to-many from the students to courses, and I have one-to-many from the courses to students. And the only way I can do that is by putting a bridge table as we studied, and the connections will be called many-to-many. Okay? Here I mentioned also the bridge table, don't forget that. You might see questions on, can I have a many-to-many without a bridge table? Definitely not. Okay? Let's see the next question. Which type of a link you should establish between the students table and the lecturers? Usually you want, not usually, it's really nonsense to have a direct link between students to lecturers. We know that there is a link between students to courses, there's a link between lecturers to courses, and therefore there will be a link between students to lecturers, but not a direct one. Therefore, the answer is there is not direct links between these two tables, only indirect link between them, okay? Don't get confused. One-to-many it will be incorrect, or many-to-one will be also incorrect, because I usually won't connect students to lecturers in a direct way. In fact, 26 is something I mentioned before. The students table will include information about the students, which additional fields it should include, okay? And here I mentioned a link to a bridge table. The only way I can connect many-to-many, it's just by having a bridge table. And the connections of the students, okay, has to be through a bridge table to the courses table. Let's move on to 27. That's a different question. Here we have another select question. Please pay attention. I try to trick you, and please don't get confused. We have aggregation functions. They are all working on the same column. On the column hourly rate, I have the count, which is a aggregation function on hourly rate, and here I call it HR count. Here, the name of the column will be HR average, etc. We have max, mean, all of the common one that we have, standard deviation, variance, but all of them working on the same column called hourly rate. So what do I get in this query? And the hint is that we have employee ID in here, and we have employee ID also in the group. So if I have employee ID in the select and also in the group, that means it's going to do all those statistics per employee ID. In other words, as then we will get number of rows in this query as the number of employees, because for every employee, I will get all those statistics. If I wanted to get the information for all employees together, and thereby I will get only one row, I just can delete the group by, and I should not forget to delete the employee ID from here. And that's one would give me only one row in this example. So C would be correct for this type of a query. And the previous query, where the answer is the number of employees. Let me put those ones back. And by the way, there should be a comma there. There should be a comma, by the way, right after the employee ID. Question number 28. In the following query, the hours table, 1, 2, 1, 2, 1, 2. Question 28. In the following query, the hours table includes information that the employees fill up about the number of hours they worked and on which projects they worked. What is the result of the following query? Pay attention. the hours include information that they fill up about which kind of work they did and on which projects. On the other hand, there's another table here in the query called people, and the people include information about the employees. I took it right from the tables we used in class. So those two tables should be familiar to you, okay? Pay attention that this query is a little tricky. I covered it in the introduction to the SQL video. Pay attention that here we have a complete query. This part of the total query called a subquery. It has a very important function here. What we're really getting from this query, it's a list of employee ID from the people table of all the employees that were hired before June 9, 2003. So the purpose of this subquery is to give me a list of employees ID that fulfill some criteria. In this case, that they were hired before a specific date. After I have the results from the subquery, the main query, okay, will give me the information from the hours table, okay, not from the people table. It will give me all the columns of the hours table in which the employees are filling which kind of jobs they did and how many hours they spent, okay? But for which employees it gives me from the tables of the hours. Only the employees that they are in that list. And those employees are the employees that were hired before that specific day. Therefore, A, it returns the reporting information. Pay attention to the word reporting information, of course, from the hours table on the employees that started to work before the 2003 June 9. Okay? All the rest are nonsense answers. I think this is the last question. So this is just to remind you that there is other command for update and delete. They're quite similar. Here I just focused on the update. Please see the other video I mentioned before to see how the delete command works. So what is the results of the following query, which include, no, it's not include subquery. Subquery was only in the previous question. Please accept my apology. I will just delete this one from here and I will upload this file. I will upload this file again after those corrections. Okay, so we have update this table called people manage, okay, in this database, okay. I mentioned in class the meaning of this one, but it's less important for our purposes. So we're updating this table, but what do we updating? We simply setting the locations to be Nashville. The way this command is written, we're not making any filtering on which records to update. Therefore, it will update all the records. If I wanted to filter by specific criteria, I should include here the where command, okay, and give here the criteria that I want on which the record to apply. Since this one, we don't have that one, there is no condition on which records to apply this setting. Therefore, the command will update the whole field location, meaning the whole column. So all the rows will be affected. All the rest are really nonsense answers. Okay, thank you. Hopefully this will be helpful and good luck in your exam.